Welcome to the second lecture from chapter number 4. Welcome to the second lecture from chapter number 4. We'll study polycrystal silicon in this lecture. Before this, we have studied few methods of fabricating silicon dioxide in our last lecture, the native oxide and the vapor deposition techniques. So polycrystal silicon is formed by depositing more silicon atoms on top of the silicon dioxide. In modern MOS transistors, the gate is formed of polycrystal silicon instead of metal. MOS stands for metal oxide semiconductor, where metal refers to the material, which is a metal that is used to make the gate terminal of a regular MOS transistor. But in modern VLSI design, the gate is not formed by metal. It's no more made of metal, but it is made of a special material. We call it polycrystal silicon. The symbol of polycrystal silicon is this. In a rectangular shape, in a rectangular box, we have dots inside representing a polycrystal silicon. It is made by depositing more silicon atoms on amorphous silicon dioxide. When the silicon dioxide is yet not crystallized, we add more silicon atoms. This forbids crystallization and makes something that we call crystallites. This material, crystallites based material, is known as polycrystal silicon and has a conductivity better than silicon dioxide. We already know that silicon dioxide is not a conductor, it's a good insulator. So polycrystal silicon is a better conductor than silicon dioxide. Polycrystal silicon is also called poly as a short. There are different advantages of having polycrystal silicon instead of metal or replacing metal with polycrystal silicon. Perhaps the biggest advantage is that it can work at higher temperatures that are common in modern VLSI based fabrication techniques. Secondly, it can be used, it can stick to refractory materials like titanium and platinum that we use as a part of gate. So in modern VLSI design, the gate is composed of the polycrystal silicon, and on top of it we have a thin layer of platinum or titanium, because it reduces its resistance, or this combination makes the conductivity of the gate terminal better than it already is with polycrystal silicon. So adding platinum or titanium as a thin layer on top of silicon or polycrystal silicon based gate increases its conductance or decreases reactance. Right. Chemical reaction to add more silicon atoms on top of silicon dioxide when it is yet not crystallized is silicon hydride is decomposed at a temperature between 500 and 600 degrees centigrade. It decomposes silicon hydride. Silicon hydride is a gas into the solid. It's a gas. So it decomposes into the solid and this gas. So silicon atoms are added on top of silicon dioxide using this chemical reaction at around 600 degrees centigrade. The symbol of poly is this, and it is used, and we know that MOS is called MOS because it is made of metal oxide. Oxide comes from silicon dioxide, this layer, and this S semiconductor. So since MOS is given the name MOS because we have a layer of metal, a layer of silicon dioxide, and a layer of silicon dioxide, and a layer of semiconductor. Right. In modern silicon, in modern VLSI design, we don't use this metal to fabricate this gate material. Rather, we use the material polycrystal silicon instead of poly because it can withstand higher temperatures that are common in modern VLSI design. Right. That's all for this lecture, and in the upcoming lecture, we'll see fabrication techniques for metals in a semiconductor IC chip. Thank you.